Okay, everybody, now that we're back inside from collecting the data, let's make sure we've got it down correctly, and then let's see what we're going to do with it. First, if you remember, I measured the height of one step. That's 0.175 meters after we converted it from centimeters. The number of steps was 22 to go from the first floor to the second floor. Now, what is this? This is my mass. Since I was the object being lifted, we need to use my mass, which I have a scale that you can step on, and it reads both pounds and kilograms. So I read off my kilograms since that's what we need it in, and it's 80 kilograms. All right, now we timed me going up two times, and the first time I'm going to call the slow time because I didn't go as fast. I just sort of walked up, and that was 15.25 seconds. Now you check your data and make sure that's what you wrote down. The second time I did it faster, so I'm going to call that the fast trial, okay? And that took 10.36 seconds, okay? So I did one slower, and one faster. Took less time. Now, how do we use this information to determine the power I generated when I did the work of lifting myself up the stairs? Well, let's take a look. First off, we need the force that I exerted to lift myself. Well, in order to lift myself, I have to use a force equal to my own weight, which is mass times the acceleration in free fall. So that would be 80 kilograms times 9.8 meters per second squared. That's the acceleration in free fall. My 8 didn't look too good. And if we multiply that out, we're going to get a value of 784 newtons that I exerted to lift myself up the staircase, okay? Now, in order to get the work done, not only do I need the force I used, I need the distance I did it over. That would be the vertical height of the staircase from top to bottom. What's the vertical height? So we said that would be the height of one step, which was 0.175 meters. There it is, 0.175 meters, times the number of steps that we had to go up, and that would be 22. If we calculate that on the calculator, we get 3.85 meters. So now we have the force used and the distance through which it was applied. And if you'll remember, work is the force times the distance, okay? So now you should be able to find the work done using the force and the distance, and then using the times, you can calculate the power I generated in each trial, okay? So trial 1, that would be the slow one, and then power 2, that would be the fast one. Now remember, I did the same work each time because I used the same force over the same distance. So the work doesn't depend on how fast I did it. If you remember and look back at the work formula, work equals F times D, there's no time in it. So work does not depend on time, but power does. So I did the same work each time, but I did it in a different amount of time, which means I generated a different amount of power. Now here's the fun part. Too bad y'all couldn't be here to do this because it's always lots of fun to see who can go up the fastest and generate the most power. But what's even more fun is to see how much horsepower one generates. So to get your horsepower, which we said is another measure of power, you take your power in watts that you just found and you divide by this conversion, 746. That will convert your watts to horsepower. Isn't that cool? And you can do it for each trial. Then I want you to answer the 3 questions at the bottom, and then you can scan and submit it. It's a pretty simple lab, isn't it? It's not too tough at all. All right, you have fun with this. Make sure you get it done and submitted, and I'll see you soon. Bye-bye.